everyone! In this video, I will cover basic scripting with Luau in Roblox Studio. If you're a beginner or if you aspire to develop games on Roblox but don't know how to start, this video will help you a lot. I will cover all fundamental scripting concepts in Luau with examples. Before beginning, please don't forget to like, comment and subscribe to support the channel. Let's begin. I have created an empty project. You can see that the Explorer, Properties and Output windows are open. If they don't show up in your project, you can go to View and open these windows up. If you don't know your way around Roblox Studio, make sure to watch the Roblox Studio Basics video. The link is in the card and the description. Let's start by creating a script. Scripts are used for creating functionality in our games. These can be behaviors or instructions that make our games interactive. Let's create a script. I go to Server Scripts service and click on the plus sign next to it. From the list, I select Script. The newly created script comes with a line of code. It says print hello world. If we run the game without making any changes, by clicking this arrow here and selecting run, you can see that hello world is printed out in the output window. Let's stop the game. We can rearrange the script windows by left-clicking the handle and moving it around. Let's dock it here so that we can see the game view and the script side by side. Scripts run line by line from top to bottom. There's only one line here that says print hello world, and it created this line we see in the output window. We can change this. Let's type hello Roblox world. If we save and run again, it says hello Roblox world in the output window this time. The most fundamental part of programming is variables. Variables are like containers. We can store some information in these containers, and also we can update values of variables and use variables in our scripts. Variables can be of different types. Let's create some variables. Let's begin with a number variable. We can name it variable 1. Then we put an equal sign to set it to a value. Let's type 10. Let's create a string variable. Variable 2 is equal to hello exclamation mark within double quotation marks. With string variables, we need to use double quotation marks. Boolean is another variable type that can be either true or false. Variable 3 equals to true, or it can be false based on the logic we need in our game. There are more advanced variable types, such as tables. We are gonna talk about tables in a few minutes after we cover the basic types. We can print out variables as well. In the example before, a string was supplied within quotation marks. Instead, we can directly put variables inside print, like this. Variable 1, variable 2, variable 3. We want the script to print 3 variables. It is gonna print out the values of these variables. Let's run it. As you can see, it printed out 10, hello exclamation mark, and false. So it printed out the values that are currently being stored in these variables. Let's take a look at another common usage of variables in programming. Let's create a part, like block. We can move it a bit. Let's anchor it so that it doesn't fall down due to gravity. As we select the part in the Explorer, you can see that there are several properties on the Properties window. These properties are variables as well. We can see the values of these variables and we can make some changes on these variables. Let's try to change the color of this part with a script. This part is under Workspace and currently named as Part. Let's rename our part to Colored Part. Name is a property of the part. As you can see, its value has changed here. If we hover over color, it says color 3, which is the type of the variable. We are gonna change this variable with our script. To make any changes on it, we first need to find that part. We know that our part is under Workspace and its name is Colored Part. We first need to access the root of the hierarchy. We'll then make our way down there. The root of the hierarchy is called Data Model. We can access the root by typing game. Game refers to the root of the hierarchy, and everything we see here like players, lighting, etc. are children of the game. Here we can type dot to go down one level. Workspace is a child, so we type workspace. It helps us by offering matches to what we type. We can select workspace. Under that, we have our colored part as another child. Let's start typing and it offers us the colored part. Great! Properties are also children of objects. So all these properties here are children of our colored part. We want to access color, so we can type dot and color. Now we want to change its value, so we put an equal sign here. It will be just like setting values to our variables here. We will put in a new value and it will update the values stored in that variable. Color values are a bit different than the simple values that we have covered so far. Color tree is a special data structure defined in Roblox, and we can use its new method, which is also defined in Roblox, to create a new color value. We go color tree. Since this was of type color tree, we can use color tree. Then we type .new. There's a very helpful editor option here. We can just click this icon and select our color from here. Let's pick red. So these are the numerical red, green, blue values that make up the red that we chose. If we click run, this line of code will be executed. This variable's value should be changed to the color value that we created here. So let's run it. As you can see, it turned to red. If we expand here and click our part, you can see that the color value has changed. If we stop the game, it goes back to its original color. So we are not changing it permanently in the properties, but changing it dynamically through the script. We can also change the other variables here. As you can see, there are lots of variables here. Let's change the value of transparency. How can we do that? It is very similar to what we just did. We can access the part by typing game.workspace.coloredPart again, but this time we'll go .transparency. Transparency is of type number, so we can directly type a number here. Let's go with 0.5 so that it is half transparent. When we run, we can see that our part became semi-transparent. We can see the horizon line behind it. We can always change most of these properties with scripts, just like how we did. Let's talk about comments. Comments are explanatory lines that are excluded from execution. They are added to code to make it easier to understand what is going on in the code at a later time by us or other collaborators. To add a comment, we can use a double hyphen. Typing this converts the rest of this line into a comment, so anything we type after the double hyphen will be excluded from the code's execution. Let's add an explanatory comment here for us to remember later what this part of the code does. Let's type changing color. Instead of adding comment lines on top of code parts, we can add comments next to code lines as well. Like this. Let's delete this. Sometimes we may want to add longer comments that take up multiple lines. Let's say we want to add a comment that says changing color and transparency of the part called colored part in multiple lines. If we add a double hyphen at the beginning, it will only convert the first line into a comment, not the remaining lines. We can add a double hyphen at the beginning of every line, like this, but there is a more practical way of adding multi-line comments. We can create a comment block by adding double brackets to open and close the block, and using a double hyphen at the beginning, like this. We can add as many lines of comments as we want inside a comment block. Multi-line comments are not really common in simple scripts, so let's go ahead and delete this, and we can use end-of-the-line comments in our code for now. Another good usage of comments is disabling parts of the code for debugging, for example. To comment out lines, we can select the lines and press Ctrl/ keys on our keyboard. It will comment out the lines and exclude them from the execution of the code. This is an easy way of disabling parts of the code without actually deleting. Let's undo this. We can also store some references in variables as well. For example, instead of repeatedly typing game.workspace.coloredPart, we can create a variable that stores this information and use that variable whenever we want to access colored part in our script. Let's do that now. Let's call our variable coloredPart. It will be equal to game.workspace.coloredPart. Let's copy this part and comment out. Let's paste here. Instead of using game.workspace.coloredPart, we can just use our variable, like this. When we run, our part is red and semi-transparent again. This is another way of using variables. Let's create another part, space it apart a bit, rename as coloredPart2. I'm gonna copy this and paste here. This time, the variable name will be coloredPart2 and the reference will be to coloredPart2. Let's replace these with coloredPart2. This time, we will be changing the color and the transparency of both parts. Let's run. As we can see, we can alter many parts like this. But there's a better way of doing that. And it is to do the changes for one part and then put the script inside every part that we want. This way, the parts will change their own color. And if we duplicate the parts, they will come with their attached scripts. So all the parts will be able to change their own colors. Let's do that now. Let's delete colored part 2, delete this part of the code. I'm gonna comment out this part after copying. I'm gonna create a script directly under the colored part. To do that, I click on the plus sign next to it and select script. I'm gonna change its name to color changer. Let's put the color changer script here as well. Delete this print line and paste our code here. We need to make some updates on our code. This time, we have the script under the part, so referring to the part will be different. We can just refer to the parent. Let's create a variable called part and refer to the part that is the parent of the script. Let's type is equal to script. Script is a special variable that refers to the script that the variable is used inside. So in our case, it refers to the color changer script. The parent of the script will be colored part. So we can type .parent. As you can see, this script here has a property called parent that refers to its parent, colored part. So we are assigning the value of this property to our part variable here. We can delete this line because we already have a reference to the part. I'm gonna use this part variable for changing the color and the transparency. Let's save it and go back to our previous script. Everything about the color and transparency change is commented out, so it will not do anything. Let's go back to our new script that is attached to the parts and run. As we can see, it changed color and transparency. We can duplicate this part many times, and when we run the game, you can see that each part is changing its own color and transparency through the attached script. This is an easy way of modifying multiple parts by using scripts that are directly attached to parts and then duplicating them. We have talked about using different types for variables. One of the most important data type that is used in Roblox programming is tables. Table is a data type that can store different values. These can be numbers, booleans, strings, or these can be other tables, functions, etc. Creating a table is very easy. Let's call our table enemies. To make it a table, we should use curly brackets. This is currently an empty table. If we want to create some variables inside the table, we can define them here directly, like small enemy, big enemy, and maybe a bus. As you can see, I have created them by using double quotation marks and commas between them. This means that these are 3 string values. If we create a table like this with only values, it will behave as an array. An array is a list of values that are indexed with integers starting from 1 in Roblox Studio. The index will be 1 for the first element in an array, 2 for the second element, and so on. In Luau, we don't actually have arrays, but this implementation of the table will behave like an array. We can print the values of the enemies table. Let's first use a string to distinguish between the elements. Inside double quotation marks, let's type 1 colon. We can print multiple values by using commas. So let's add a comma here and add our second value, which will come from the first element of the enemies table. So we type enemies and 1 inside square brackets. This line will print out the first element of the table, which is small enemy. Let's copy this and paste 2 times. Let's update these as 2 and 3. This code will print out the elements of the enemies table on separate lines with their distinguishing numbers coming from the strings at the beginning. Let's run. We can see 1 colon small enemy, 2 colon big enemy, and 3 colon bus. We can reach out to different elements in a table by using index numbers starting from 1. Other than arrays, tables in Roblox Studio can also behave like dictionaries. In dictionaries, we have keys and values, like searching for words in a real dictionary. Let's create another variable that will act as a dictionary. Let's call it enemy damage values. We'll use curly brackets to create a table, but this time we'll add small enemy without double quotes, meaning that it will be a variable name like how we have variable 1 and variable 2 here. And we'll set it to a value, let's say 5, like setting a normal variable. Let's add another variable, add a comma, big enemy equals to 10. Another comma for the third variable, but its damage value can be 20. This time, our variable will behave like a dictionary because it has variables with some values inside. The variables will act as keys and we will be able to use them to find the values, similar to a dictionary. As you may have noticed, what we put inside a table determines how the table will behave. Let's print these out as well. To distinguish, let's first add the string small enemy, comma, enemy damage values to refer to the table, square brackets again, and we need to refer to the variable by typing the variable's name inside double quotation marks. Let's copy and paste twice. Update it for big enemy and boss. Let's save and run. We can see our previous print lines here. And at the bottom are our new lines that show the values in the enemy damage values table. So we can store multiple values or variables inside tables. Let's comment these out for now and talk about loops. Loops enable running a block of code over and over. Let's go back to the color changer script, which was changing the color of a part to red and the transparency to 0.5. Let's assume we want to do it 3 times with random colors. Let's comment out this part, copy this code that changes the color. This time, I don't want to give any exact color value, but pick the values randomly. For this, we can use a math library that gives us a random value. We can type math.random. This is a function that returns a value between 0 and 1. We'll talk about functions in a few. This random value is for red, and we need to repeat it for green and blue as well. So all 3 color values will be assigned randomly. This will be our first color. We want to change it 2 more times, but we want the change to be visible. If we copy and paste this twice and run the code, we will not be able to see all color changes because all code lines will be executed immediately one after the other and we will not be able to see the color changes visually. To be able to see these changes, we need to wait for some time. We can use the wait function for this. Inside, we can put in the number of seconds we want the code to wait. Let's use 1 so that it waits for 1 second. Let's copy and paste it after each color changing line here. Save and run. We can see that the color changes 3 times. If we want to change it 5 times, let's say, we can copy and paste this twice more. When we run again, we can see that it changes to a random color at every second for 5 times. What if we want to change it 100 times? Copying and pasting this line for 100 times is not an efficient way. For scenarios like this, we have loops. There are different types of loops. The first type that we are gonna cover is the for loop. Let's delete these extra lines here. Let's comment this out and create a for loop. We type for. It will create a loop for us that will be repeated for a predefined number of times. First, we need to create a control variable. It is typically called I, as in index. We need to set it to an initial value. Let's use 1. Add a comma. We need to add the end value for the index. Let's type 5, meaning that we want it to repeat 5 times. And the last value will be the increment. If we type 1, which is the default value, the index will increment by 1 until it hits 5. If I press enter on the keyboard now, it will add the do and end keywords for me that define a for loop block in Roblox Studio. Inside the loop, I want to assign a random color to the parts like how we just did. So I copy and paste here and remove the command to make the lines executed. When we run this, it changes color randomly for 5 times and it stops. It would be good to see the index value in real time. We can add a print line, type I equals within double quotation marks, add a comma, and add our variable I. If I run the game, you can see the index value printed here from 1 to 5. So if we want to have some repetition in our game and we know how many repetitions that we want, it is a good practice to use a for loop instead of copying and pasting lines over and over. Another loop type is while. Let's comment this out and create a while loop here. We type while and inside parentheses, we need to add a condition. As long as the condition is true, the while loop will keep repeating. For now, let's type true and it will be repeating this while block forever as long as the game is being run. Let's copy and paste this part and uncomment. When I run, we can see that it changes color at every 1 second until I stop the execution of the game. If we want something to repeat continuously as long as the game is being run, we can use a while loop. We can have the while loop repeat for a predefined number of repetitions as well. To do that, we can create a variable outside the loop. I is equal to 1. This is our variable. Let's print out I here as well so that we can keep track of that. In the for loop, the I was being incremented automatically. But in a while loop, there is nothing like that. But we can edit ourselves. We can type I is equal to I plus 1, which will add 1 to I every time this code line is executed. And here, instead of using true, we can type if I is less than 6. So it will start from 1 and it will get incremented by 1 until it reaches 6. And when it is 6, when the code execution is at line 16, it will calculate the condition I is less than 6, which will return false. So the code inside the while loop won't be executed. Let's run. 1, 2, 3, 4, 5, and it stops. So loops are used for repetitive behaviors. Conditional statements are also used commonly in programming. Let's talk about that now. Let's copy this, paste it here, and uncomment. Here, I'll type a conditional statement, an if statement. It is similar to the condition inside the while here. After printing I'll go if. After if, we need to add the condition. Our condition will be I modulus 2 is equal to 0. Here, I've used double equal signs because this is not a value assignment but a conditional check. It is different than assigning values with the single equal sign. With a double equal sign, we are checking if I modulus 2 is equal to 0, which is actually checking whether I is an even number or not. If I press enter here, you can see that then and keywords are added automatically and an if block is created. Inside the if block, I'll type print, and inside double quotation marks, meaning that this will be a string, I'll type I is even. When I click run, you'll see that when I is even, like 2 and 4, I is even is written here. When the code is executed in this line, Roblox Studio checks if this statement is correct. If it is correct, it means that this part of the block will be executed. If the statement is not correct, when I is not divisible by 2, the execution will skip this line. In if statements, we can use else blocks as well. Instead of and, we can type else here and press enter. We now have two blocks, an if block and an else block. The else block will be executed if the condition in the if statement is not true. Let's copy this and paste here. Update it as I is odd. This time we have I is odd and I is even lines printed based on the value of I. This covers the basics of conditional statements. Before moving on, I'm gonna show you another usage of loops. Let's go back to the script here. If you recall, we have enemy and enemy damage values tables here. The enemy table is like an array. It stores values that can be accessed with indices such as 1, 2, and 3. And the enemy damage values table is like a dictionary. It stores variables as keys and values. In this example, we had 3 elements in each table, and printing them out was easy. But if we have more elements, we would need to keep repeating print lines. Instead of that, we can use loops here. We'll use a special type of for loop that is used with tables. I'll type for I, v. So we have 2 control variables here, I and v for index and value. I'll type a keyword in and another keyword I pairs. This I pairs will go over all the pairs of the elements in the table. Inside the parentheses, we should enter the table name, which is enemies. When I press enter, it will create the block. This will take in the enemies table and it will loop through all of these entries in the table with the control variables I and v. We can use a single print line here and use I and v so that the index and the value are printed. When I hit run, 1 small enemy, 2 big enemy, and 3 boss is printed out without having separate print lines for each of them. This is how we can use for loops for tables that behave like an array. And for tables that behave like a dictionary, it is similar but a little different. Let's do that one too. Instead of I and v, the common way of writing this is with k and v for key and value. And instead of I pairs, we can type pairs. Inside, we'll pass in the table name again, this time enemy damage values. I'm gonna change this to k since we have k as our control variable. Let's run. As you can see, small enemy 5, boss 20, and big enemy 10 is printed. You might have probably noticed that all keys and values are printed out, but they are not sorted. It is not usually important for tables. We can use a for loop to iterate through all values in a table, but we shouldn't rely on the sorting while using a for loop with pairs. Let's comment these out. Now let's talk about variable scopes in Lua. When we don't specify anything, a created variable scope is global, like all the variables that we have created here. Global variables can be accessed from outside code blocks. Local variables can only be accessed from the same code block. For technical reasons, creating local variables instead of global is much more efficient in terms of execution. Let's come here and convert these variables to local variables by typing local in front of them. Let's also convert the tables to local. In general, we should always use local variables in Lua because it is more efficient, and in almost all scenarios, we can implement our code with local variables in Lua. If we create a local variable inside a code block, like a for loop block, we cannot access it from outside that block. But we can always create that variable outside the for loop block with a local scope and use it inside and outside the for loop block. Let's go back to our color changer script and talk about another programming concept, functions. Functions are blocks of code that we can execute multiple times on demand. They are typically used for adding behaviors to games. Let me show you with an example. Let's change this part variable scope to local as well. I want to move this part up a bit in the game, so I need to update its position value. I can type part.position. Position is of type vector3. See, there are 3 numbers here. Is equal to part.position, and let's add a value to its original position. Vector3.new similar to color3.new. I want it to move upwards, so I use 0, 5, 0 for the x, y, and z values. When I run it, the part is immediately moved upwards. Let's add a wait here for 4 seconds to be able to see the position change more clearly. When I run it, after 4 seconds, it moves up. Here we have a single line of code, but sometimes we may have multiple lines of code, and repeating those lines every time we want to apply the same things on a new part would be tedious. Hence, creating a function and adding those code lines inside the function would be more efficient. We would then only need to call the function whenever we wanted to execute those lines. To create a function, we use the function keyword, and then we can type the name that we want to give to the function. Let's call it move up. We add parentheses here. Inside the parentheses, we'll add parameters that we can use inside the function. So let's assume we add a parameter for the part here. So the part will be supplied whenever this function is called. If I press enter, a block will be created with the end keyword. Inside the block, I'll type whatever I want the function to perform. Let's copy and paste this inside the function block. Here, I'll use underscore part instead because underscore part will be supplied when this function is called. Let's comment out these previous lines. Functions can be local or global as well. I'm gonna make it local too for efficiency. We have created our function. When we run our game, nothing will happen because we didn't call our function. So creating a function doesn't make a change in the game. We need to call that function for it to be actually executed. We can go wait for and call the function by typing move up parentheses. Inside the parentheses, I'll type part, which is the script's parent as created here at the first line. If I click run, the function will be called after 4 seconds and the code inside the function is executed, moving the part up. When execution hits line 45, it will search for the move up function and then execute the code lines inside it. Let's copy this for loop from here, paste here, and uncomment. Let's update the upper index as 3. I'll delete these lines. I'll cut these 2 lines and paste here. Let's run. It will go up once, twice, and 3 times. So we can call functions inside loops as many times as we want. Our final programming concept is events. An event is a data type that represents an action or occurrence within Roblox. We can connect functions to events so that every time an event is fired, we can do something in our game based on that. When I type part and dot, we are presented with variables and events. The ones with a lightning bolt next to them are events. There are different events as you can see. We are gonna use the touched event in our example. Whenever something touches to this part, this event is fired. To connect to that event, we should type :connect. Inside the parentheses, we should either type the name of a known function or create a function ourselves right here. That function will be called whenever the touched event is fired. Let's create a new function. So it is gonna be a function, hit enter, and we'll type our code inside this block. Inside this function, we can type whatever code we want to get executed when the event is fired. Let's call the moveUp function with the part variable. If I click run, our part isn't moved at all because nothing is touching it. If instead of running the game, I click play, my avatar is spawned in the game and I can move around. I can touch it with my avatar's head. As you saw, as soon as I touched it, it moved up. I can jump to touch again. It went up again. This time a bit more because multiple parts of my avatar touched the block when I jumped up and down, and it moved up for every contact that was made. This is how we can use events in our games. So that is pretty much it for this video. I hope you enjoyed it. Please like and subscribe to support the channel. If you want a new game development tutorial, let me know down in the comments. You can get access to the Roblox project file from Patreon. The link is in the description. Thanks for watching and see you in the next video.